There are some rules of thumb when writing deviations, root cause analysis reports, and CAPAs. First of all, be clear and specific. Use the 5 W's and 1 H method. What, who, when, where, why, and how. Be clear and specific. Give exact and precise data. In deviations, write only facts, data, or observations prior to, during, and/or after the event. Write all details in chronological order. Mention all the available information, such as the names of people, equipment ID and instruments, date, time, and so on. Provide information on how the event was controlled and/or limited at the time it occurred. Be concise. Do not overextend the explanation and do not repeat yourself. Explain the facts without explicitly stating why. Explain the requirements or the specifications that have been deviated. Reference the relevant guideline, regulation, or policies. Indicate the clause number, paragraph, etc. Root cause analysis is a systematic approach to investigating the true root cause of an event or deviation. There are different tools for performing root cause analysis. Some organizations use the 5 whys process or the Ishikawa diagram, for example. There are many other options as well. In any case, the investigation should clearly describe all of the findings based on evidence. If the investigation is related to an out-of-specification result in quality control, a full in-depth investigation should be carried out to determine whether a possible analytical error has been made. This means a full revision of the analytical process, sampling, reagents, instruments, and procedures is needed. The historical data needs to be trended and analyzed. From there, plan to summarize the results in tables and graphs. It is crucial to report the affected materials and batches because a deviation may affect the product quality or other related products. Therefore, the potential risk should be addressed immediately. In addition to reporting the affected lots, you will want to report any other lots that could have been affected. If the root cause is not found, then you must propose the most probable root cause based on a scientific hypothesis. Note that root cause analysis may come to the false conclusion that a human error or an equipment failure is the root cause of the problem. Although these reasons can be valid, you must go further and apply effective CAPA actions. CAPAs need to tackle the root cause. For example, performing a training session is not always the unique and best CAPA action. People can make errors if a procedure is not well described. As such, the CAPA action should be able to improve the procedure or modify the process. There are some rules of thumb when writing SOPs and work instructions. Define the scope. What, where, and when. Define the responsibilities. Describe the purpose for work instructions. Think about the end user of the SOP or work instruction. As commented, it is part of the documentation plan. It will therefore vary based on the target audience, which may be an operator, an analyst, a manager, an auditor, the regulatory bodies, etc. Write in a concise, step-by-step, easy-to-read format. Present each idea clearly and concisely. Use the active voice over the passive voice. Use present tense verbs. Use action verbs. Instructions should not raise questions but give answers. Include references and links to other documents to extend the details. Use steps and stages to describe a process. Use lists and bullet points appropriately. Write short sentences and paragraphs. Use simple language. Use understandable formats, tables, diagrams, pictures, etc. when needed. Include an abbreviations list. Use print screens for IT procedures. And there you have it. With these insights, you now have a solid grasp of effective technical writing in the life sciences. Thank you for attending this course. I hope you find it useful and that you have learned what you expected. See you in other courses at Scilife Academy to continue your learning journey.